Today's lesson, chapter 4, lesson 6, is about constructing functions. What will we learn today? To find and interpret the rate of change of a function and the initial value of a function. So stuff we've already talked about before in different lessons, but now we're going to be looking at it in real-world problems. Real-world example number 1. A shoe store offers free points when you sign up for their rewards card. Then for each pair of shoes purchased, you earn an additional number of points. The graph shows the total points earned for several pairs of shoes. They want us to find and interpret the rate of change and initial value. So number 1, rate of change, and we need to interpret it. And number 2, initial value, and interpret what that means. So let's start with rate of change. So our rate of change, there's a couple ways of doing this. What I'm going to use for my rate of change, I'm going to use rise over run. Since we have a graph here, I'm going to start at my first point. And at this point I'm at 2, that's 0.260. And then it's going up to the next point, which is 490. So let's look at this. My rise, it looks like it goes up from 60 to 90. We can pretty much say 90 minus 60, which is 30. So my rise is 30. And then my run, I'm going across from 2 to 4, that's 2. So 30 divided by 2, we know is 15. So 15 means, our rate of change is 15, and it's 15, and we're going up, talking about points, 15 points per pair of shoes. So we found the rate, and we interpreted it. Let's look at our initial value. Now you see in this graph, they've taken from the point 260 and it's brought it down to the y-axis. Our initial value is always on the y-axis. In this case, we have an initial value of 30. And again, it's points earned. So our initial value is 30 points. And if it's initial, it means it's starting. So you start with 30 points. So 30 points started with. And now we found and interpreted the rate of change and the initial value. Real world example number 2. Joan has some photos in her photo album. Each week she plans to add 12 photos. So let me write that down. Each week adding 12 photos. Joan had 120 photos after 8 weeks. So at 8 weeks, she has 120 photos. Assume the relationship is linear. What that means there is that you're going to have a constant rate every week, and we know that she's adding 12 photos a week, so it's never going to change. It's going to be an exact 12. Not 11, not 13, exactly 12. That's what this phrase here, assume the relationship is linear, means. Find and interpret the rate of change and the initial value. So to find the rate of change, what I can do is if she has 120 photos, the rate of change, I was getting ahead of myself. The rate of change, we're being told right here, each week she adds 12 photos. So 12 photos per week. That's our rate of change. They give it to us. They want us to also find the initial value. So we know that at 120, she had 120 photos at week number 8. And she's been adding 12 photos each week. So I'm going to take my 12 photos per week, or my rate of change per week, multiply that by 8 weeks, and see what I get. Or 12 times 8, which is 96 photos. So she added 96 photos. She has 120 at the end of 8 weeks. So in order to find our initial value, or what she started with, I'm going to take 120 minus 96. And that's going to give me 24. So the initial value, 24 photos, is what Joan started with. They put a square on both my answers, rate of change, and initial value. Another example where we're going to find the rate of change and the initial value. So let's look at example 3. The table shows how much money Ava has saved. Assume the relationship between the two quantities is linear. Again, that means we have a constant rate of change. Find and interpret the rate of change and the initial value. Is that? So number of months. So we're starting at month 3. So we're going up going up by 1. And it looks like from 110 it's going up by 20s. So we can say the rate of change is money saved. Again, our Y column, our 20 is the amount saved. $20 per month. Now, they want us to find the original or the initial value. A couple ways of doing this. I mean, I'm at 3 months there. I can reverse. Subtract 20, which will give me 90, and that's at month 2. Subtract another 20, that's 70. That's month 1. Now that's the first month. We have to go all the way to 0. So let's subtract another 20, and that gives us 50. The initial has to be where she started at 0. So the initial value would be $50 is what she started with. And if that, we can look at that, does that make sense? $50 plus 20, first month 70, $50. We can even write an equation for this. We can say initial value Y is equal to $20 per month, or let's use X, plus 50. Let's check month 6, see if we get 170. Y equals 20 times 6 equals 170. 20 times 6, not equals, sorry, plus 50. So this 20, we know 20 times 6 is 120, plus 50. Y equals 170, which is what we need. So the rate of change, $20 per month. Initial value, $50.